I've had the opportunity to attend a number of conferences and trade shows on robotics and unmanned systems. I was working primarily with unmanned aerial vehicles, that is UAVs and drones, and a subset of robotics known as autonomous systems. Autonomous systems are systems that can control themselves in real time and operate independently without human control. The most talked about example these days is probably self-driving cars, but there's lots of others, everything from robotic vacuum cleaners to factory robotic automation to self-guided missiles and everything in between. Now, because of the control logic and the technology involved, autonomous robotics go hand in hand with artificial intelligence. AI involves the ability to do things like real-time assessment, decision-making, and adaptive learning, which allows robotic systems to operate and navigate in different environments on their own. So autonomous systems typically imply some level of artificial intelligence. Now, one topic of discussion that always, without fail, comes up at these technical conferences is the problem of public opinion towards AI and autonomous robotics. The big question that everyone debates is, how do we, that is the engineering and technology community, allay the public's concerns about robots and AI and dispel these myths about robots taking over the world and convince people of the phenomenal benefits of autonomous systems? Now, while different approaches are discussed and debated, the underlying assumption is almost always the same. The general public does not understand robotic technology, especially autonomous robotics, and therefore needs to be educated about how it works and what it can do. And once the public is on the same page as the engineering community, then everyone will be on board and we can all move confidently into a bright technological future. Now, I'm sure there's some truth in this. I mean, it's always good to educate the public on technical matters that have some impact on society. But I never felt that this approach really addressed the heart of the issue. And it's basically because, as a Girardian, I know that the concept of autonomy and how that autonomy is perceived plays a crucial role in how people interact with each other and with the world around them. Like many of you in this conference, when I hear the word autonomy, my first thought is not about some level of controllability. It's about that romantic lie of which Girard spoke so much. I have actually brought this up once or twice at those technical conferences, and of course it went nowhere. I mean, nobody in the engineering community really knows or cares too much about René Girard or mimetic theory. But this puts them at a real disadvantage when they're trying to understand human behavior and public perception. So I'm actually very happy to be speaking to an audience today that will understand things better and hopefully appreciate what I'm trying to say here. Now, the first thing to understand about robotics and AI is that they've been around for a while, specifically since about the 1950s. 1950 was, in fact, the year in which the term artificial intelligence was coined at the first AI conference in Dartmouth College. Incidentally, this is also the year that Alan Turing, the creator of the Turing machine and the prophet of the computer age, it's when he published a groundbreaking paper entitled "Can Machines Think?" And his approach in this paper is to postulate a situation that he calls the imitation game. It's a question and answer game made up of, you guessed it, 3 participants. Coincidence? Well, maybe. I'm actually not going to get into an in-depth analysis of Turing's paper here. And honestly, it wouldn't be very interesting if I did. The philosophical arguments made in that paper are honestly some of the worst I've read in a long time. Turing basically strips humans of anything that makes them uniquely human and then claims that machines are just like humans. So the conclusion is not really so much that machines can think, but that humans don't. But nonetheless, I think it is interesting that Turing feels compelled to judge the humanness of a machine, through the lens of imitation. I think that's important. So it's something to keep in mind when I make my closing remarks at the end of this presentation. Anyway, in the early days, that is the 50s and 60s and 70s, artificial intelligence was associated primarily with high-end military and space applications. In the 80s and 90s, it became more associated with certain decision-making applications like computer games, translation and mapping algorithms, remote control. In the 2000s, there was increasing talk about robotic dolls and robotic vacuum cleaners, and drones came on the scene. And by 2010, we were all talking about machine vision and speech recognition and quantum computers. There was actually a kind of surge in robot-themed conversations, about man versus machine and that whole rivalry in the 80s and 90s. This culminated in 1997 when IBM's supercomputer called Deep Blue beat chess champion Garry Kasparov in a 6-game match. I bet some of you remember that. This famous defeat kind of ushered in an apex of the rivalry between men and machines. So largely because of this sort of thing that was going on, there have been a number of different studies and surveys done over the years analyzing public opinion towards robots and artificial intelligence, as recorded in the media and in various publications. And it's interesting to note that according to these studies, throughout most of its development, the public attitude towards AI and robotics was generally positive. Throughout the history I just briefly outlined here, and for over a decade after Deep Blue beat Kasparov, the conversations going on in the media usually revolved around the positive impacts of robots and AI and the huge potential for the future. One historical analysis also notes that the general public tends to think of robots as instruments or machines, not as humans or humanoids. So in other words, it appears that the public has historically had a fairly clear understanding of robotics and AI as enabling technologies, as tools with the potential to help mankind. But according to the same data, it was actually around 2012 when the public attitude towards robots and AI took a decidedly negative turn. There's a kind of a shift in attitude around 2012. Now, notions of robots, wreaking havoc on society and taking over the world and all that certainly existed before 2012. I mean, the Terminator movies came out in the 80s. But there was nonetheless a distinction between these darker fictions and the more serious discussions taking place in newspapers and magazines and journals about the positive potential of robotic technology. Apparently, starting around 2012, that distinction gets somewhat blurry. And it's in response to this that the engineering community feels it must educate the public about the capabilities and the positive potential of robots and AI, to separate fact from fiction. But the historical data suggests that this shouldn't really be necessary. I mean, if we understood the positive potential of robots and AI back in the 50s and 60s, and still in the 80s and 90s, how is it that our current and much more tech-savvy generation suddenly doesn't get it? Well, the negative turn in public opinion happens to coincide with a particular development in robotics and AI, namely an increase in focus on autonomy and autonomous systems. And this, I think, is no coincidence. In fact, the data suggests that the negative attitude after 2012 is directed more specifically towards robots working autonomously in human-related applications, while the attitude towards non-autonomous applications has remained generally positive. One study notes, moreover, that people generally don't distinguish between different levels of autonomy. So, for example, different levels of driving in a car, from your basic cruise control to some of the driver assist functions that you see nowadays to a fully self-driving car. And they don't distinguish between those different levels. The tendency is to categorize robots as either autonomous or not autonomous, period. So in other words, there appears to be a kind of bipolar attitude towards robots. It's positive in relation to robotic technology overall, but then suddenly negative in relation to autonomous robots. So why is this? Well, one obvious answer is that autonomy is a measure of a robot's independence from human control. We humans don't like to give up control, especially to something that could malfunction or make some critical mistake. Well, that certainly makes sense, but let's explore this idea in a more specific context. One of the more controversial topics of discussion at those technical conferences I mentioned earlier is the debate over autonomous vehicles, self-driving cars, and the very negative public opinion preventing their acceptance in the market. The general assumption is that people don't like to give up control of the vehicle, and they don't trust the machine, in this case, the car itself, to drive them safely from point A to point B. So once again, the solution is to educate the public on the capabilities of autonomous technologies and demonstrate that a self-driving car is actually very safe. Now, the fact is, this isn't very hard to do. It's commonly known that sensing and computing technologies can detect and react to things hundreds or thousands of times faster than the average human being. And it's also well known that there have been huge advances in these technologies in the last couple decades alone. So let me just go ahead and ask the question right now. Given the impressive suite of technologies nowadays, would it surprise anyone listening here to learn that a self-driving car is actually statistically less likely to get into an accident than the average human driver? It's not hard to believe, especially considering the low bar set by the average human driver. I think most people understand, or can at least accept, the superior capabilities of robotic technology. I mean, we've been talking about them for over half a century now. So just to drive the point home, so to speak, let me ask the same question another way. Does anyone here think that human drivers are so reliable and safe that they never get into accidents? Of course not, right? The average driver fluctuates daily between somewhat focused and completely distracted. And most of us have had direct personal experience with this on the road. There are, on average, 114 traffic-related deaths every day in the US alone. That's deaths, not just accidents. Traffic-related deaths, 114 every day, all caused by human drivers. That's how unreliable human drivers are. And yet, we have no problem at all getting into a taxi or an Uber and giving full control of the car to a complete stranger. I mean, isn't that kind of weird? Getting into a car controlled by a computer that may possibly have some programming error that might cause an accident, I mean, this makes us extremely nervous. But getting into a car controlled by a person that may get distracted by anything at any moment, might just be having a bad day, that doesn't bother us at all. So giving up control does not in itself seem to be a fundamental issue for us. Now, of course, the difference between an Uber driver and a self-driving car is that one involves an autonomous human being and the other involves an autonomous machine. So maybe this is the problem. Maybe this is the heart of the issue with autonomous systems, not just giving up control, but giving up control to a machine. Okay. Well, let's test this idea out by looking at another application that's very similar to that of self-driving cars, namely the aircraft autopilot. An autopilot, as you all probably know, is a mechanism that allows an airplane to effectively fly itself without pilot control. It was invented in 1912, and by the 1970s, it was being used on most commercial aircraft. It was rapidly adopted in the aircraft industry precisely because it improved safety and reduced the chances of an accident by eliminating, quote, pilot errors. So it was well understood that the superior capabilities of this machine made things better, made things safer. Today, it's common knowledge that pilots often put the airplane in autopilot, and it's actually standard procedure on long flights. And yet, no one seems to be freaked out by this. None of the millions of people traveling through airports seem to be much bothered by the fact that they're getting into a plane that will probably be flying itself, controlled by the flight control computer. And there have, in fact, been several plane crashes caused directly by malfunctions of the autopilot system, killing hundreds of people, and they've all made the evening news. And yet, the airports are packed. So giving up control to a machine is apparently not a fundamental issue either. Now, the difference between a self-driving car and an Uber driver was fairly obvious, right? But what's the difference between a self-driving car and a self-flying plane? I mean, aren't they both autonomous systems? Well, sort of, but not exactly. In both cases, we are ultimately talking about giving up control to a machine. But the way these two technologies are understood by the average person is very different. Autopilot is not short for autonomous pilot. It's short for automatic pilot. And the difference is subtle but important. An automatic response is one that happens without any intentional inputs by a controller or by an operator. It happens on its own, automatically. If a person has an automatic response to something, it's a response without thinking, independent of or even despite the person's will or intention. It's what we usually call a mechanical response. An autonomous response is one that happens because of the will or intention of the thing. If a person has an autonomous response, it's because he or she willed it as a product of his or her autonomy. So to put it a little more succinctly, an automatic machine does what it's told to do all by itself. An autonomous machine tells itself what to do. The autopilot was invented and established in our world before the advent of artificial intelligence and the modern focus on autonomous systems. It belongs to that earlier conception of robots as high-end machines designed to increase efficiency and improve society, before we acquired our bipolar attitude towards robots as either non-autonomous good or autonomous bad. It's this perceived quality of autonomy, I think, that makes all the difference. 114 deaths per day caused by human drivers, and hundreds of deaths caused by automatic pilots. All this is apparently perfectly acceptable. But even one death caused by an autonomous vehicle is completely unacceptable. And this was demonstrated on March 18, 2018, when a pedestrian was killed in Arizona by a self-driving Uber car. That one accident flooded the news and media for weeks and set the autonomous vehicle market back at least 2 or 3 years, probably more. This radical difference in attitude towards autonomous systems betrays something deeper, I think, than a mere lack of understanding or confidence in the technology. It's something that even the most impressive technical capabilities can't overcome. Giving up control may be difficult for some people, but it doesn't prevent most of us from getting into an Uber. And giving up control to a machine may be distasteful to some people, but it doesn't prevent most of us from getting on an airplane. So it seems that the problem of autonomous systems, the root of that negative attitude since 2012, is not fundamentally about control or the lack thereof. We apparently have not yet touched the real nerve that turns the logistical problem of robotic control into something more existential, something that inspires an entire subgenre of fiction and a range of modern-day phobias, including what has come to be known as robophobia. In fact, this phenomenon of robophobia makes it even more obvious that the problem is not really rooted in robotic control or capabilities. This irrational fear, which the engineering community claims to be fighting, is broadly defined as the fear of robots using their superior capabilities to take over the world or control human beings or replace human beings altogether. But how do we reconcile this with our fear of autonomous systems like self-driving cars, which we are told is rooted in a lack of confidence in the car's ability to get us safely from point A to point B? I mean, are we afraid of robots because they're not capable enough to be safe around humans, or because they're too capable to be safe around humans? Which is it? Well, there is, in fact, another school of thought that effectively brings these two opposites together. This is the idea most famously expressed by Elon Musk and Stephen Hawking. It's the idea that robots are indeed more and more capable, but they remain incapable of making moral or ethical decisions, and this makes them inherently dangerous. I think this is actually closer to the truth because it acknowledges the role of a human-like quality in robots. In essence, robots are not human enough, that is moral enough, to be trusted with so much capability. Now, one study that was done on public policies pertaining to robotics and AI discovered an interesting distinction in how AI technology is perceived. It noted that technical experts in the field, that is roboticists and engineers, tend to define artificial intelligence as something that strives towards a process of ideal thinking or a set of ideal behaviors. In other words, AI is understood in purely computational terms. And its ultimate goal is to achieve a kind of mathematically perfect reasoning, which would yield ideal behaviors. In other words, no mistakes. The general public, however, tends to define artificial intelligence as something striving towards human-like thinking and human-like behavior. So according to everyone outside the professional robotics community, the ultimate goal of AI is not to be an infallible computer, but to be a kind of infallible human. So we can see then why the engineering community has been having a difficult time with this. While they've been defining AI in terms of controllability and capability, the general public has been thinking of AI as a measure of humanness, the humanness of a machine. So when Musk and Hawking say that robots are not human enough to be trusted with so much capability, what they really mean is that robots are not human enough to be trusted with so much humanness. What's interesting is that this apparently only becomes a serious existential problem if the measure of that robot's humanness is its degree of autonomy. That's what's come to light over the last decade. But there's still something missing. What Musk and Hawking are suggesting is that an autonomous robot will make unethical decisions because it's not guided by any sort of moral compass, just by a mathematical logic. So for example, an autonomous defense system based on some cost-benefit analysis might decide that killing a small group of people would be to the benefit of some larger group of people. It would launch a missile attack on this small group of people. So this might be a decision that is mathematically sound, but morally reprehensible to most human beings. So the problem is a lack of humanity or morality in the decision-making process. But while this does in a way reconcile the two opposites, discussed a moment ago, the fear of robots having too much or too little control, it ultimately really it's another way of reducing the problem to one of controllability and capability. And we've already seen that the root of our existential fear of autonomous systems is something deeper than that. The fact is, when we get into a taxi or an Uber, I don't think we're particularly concerned with the moral sensibilities of the driver or the potential for some moral dilemma to happen on the way to the airport. Whether we're in a taxi, an Uber, or a self-driving car, the basic concern is whether or not we'll get into an accident. And an accident, by definition, is not a moral or ethical decision. It's an accident. The primary question is not whether or not the driver will deliberately cause an accident, but whether or not he can avoid one. And the fact is that machines are better at that sort of thing than human beings. So we're back to that same nagging question. Why this categorical difference in attitude between autonomous and non-autonomous systems? Between getting into a self-controlled car and getting into a human-controlled car. Well, the answer, I believe, is that there is indeed a moral factor involved, but it comes after all the decisions are made, not during. If, God forbid, there is an accident, a human driver will at least feel sorry about it. Even if the accident wasn't technically his fault, he will still, at least in principle, feel sorry for what happened. Other people will have someone to blame or someone to forgive. A self-driving car, however, will not care and will not feel sorry and cannot be held morally accountable in any way. And this, I think, is the fundamental difference between an autonomous vehicle and a human driver. If an autonomous vehicle gets into an accident, there is literally no one to blame. It's not a question of capability, but of culpability. I actually received some validation for this idea from my youngest son, who was 12 at the time, I think. As any good Girardian knows, if you want to get a deeper insight into the underlying dynamics of mimetic desire, the best person to ask is a child. So I asked him why he thought it was so hard for people to get into a self-driving car. His answer was, a car doesn't know when it's done something wrong. I think those were his exact words. A car doesn't know when it's done something wrong. That's why people don't like to get into the car. So I pushed back on this a little bit, and I suggested, well, with a self-driving car, things should go wrong less often, right? So, isn't that a good thing? Then doesn't that make things better for people, not worse? And he shook his head at me, obviously frustrated with my naive simple-mindedness, because I was basically missing the point. It has nothing to do with how well the car can drive itself. The problem is that if a car ever does make a mistake, it won't know that it made that mistake. It won't be aware that it's responsible. And according to my 12-year-old son, no one wants to be the victim of that kind of mistake. It's not really any harder to trust a computer to make good decisions than it is to trust a person to make good decisions. In either way, there are no guarantees. But if a purely mathematical decision results in a, quote, immoral act, whose fault is it? Who is there to blame? Is there anything more tragic than someone dying for no reason, just bad luck, or worse, bad math? We humans are not merely concerned with the logistical problem of preventing evil, but with the existential problem of dealing with it once it's occurred. And we Girardians know how this is usually done. We deal with evil by transferring it onto an appropriate victim or scapegoat. We manage evil through sacrificial mechanisms. In order to manage evil and our own consciences, we need someone to blame. The problem of autonomous robots and AI is not that autonomy allows robots to make immoral decisions, which can be made just as easily by immoral people. The problem is in allowing a form of autonomy that is somehow immune to culpability, a scapegoat that is somehow immune to sacrifice. As I mentioned in the beginning of this paper, the concept of autonomy has a special place in mimetic theory. It's considered a distinctively human quality, but not just any human. Autonomy is precisely that quality that we mimetic human beings envy in our models and rivals. This envy is not based on any practical issues of controllability or even any comparison of capabilities. We don't envy our models because they're better at some skill than we are. We don't fear our models because their autonomy makes them difficult to control. We are scandalized by our models because they possess an autonomy that we lack. It's this lack, this romantic lie of our own autonomy that we desperately try to cover up as we exert our desire over against that of our model rival. This perceived autonomy empowers our rivals and infuses our models with a kind of superabundance of being that makes them, in a sense, more human than we are. We don't want to control our models. We want to be our models. This is mimetic theory 101. So the humanness that we are starting to recognize in robots, if only dimly or on an intuitive level, is actually that of a model rival. It's a humanness that is inherently scandalous. It's a kind of humanness that we instinctively resent because it threatens to be more human than we are. Now, in the case of a human model rival, it's fairly easy to keep up the lie of autonomy, both our own and that of our model rival. We human beings do, after all, have some measure of free will and independence, and we are ultimately responsible for our actions. This is what we exert over against the influence of our models in our attempts to deny that influence. But in the case of robots, the objective lack of true autonomy, that is, the lack of actual humanness, is unavoidable. Remember the findings of the surveys that I mentioned earlier. People tend to think of autonomy and AI in human-like terms, but they tend to think of robots themselves as machines or instruments. That is something categorically different from human beings. So our image of robots then is becoming somewhat paradoxical. As robots cross a certain threshold of perceived autonomy, they're becoming too human, but too human for something that isn't human. It's not that robots are getting better at imitating humans. It's that this relatively new quality of autonomy is making robots too human for something that isn't human. The closest analogy that I can think of is another favorite of science fiction and horror movies, namely zombies. The main reason zombies are so disturbing, I think, is that they are, decaying corpses that are somehow walking around causing trouble. They are dead things that are somehow too alive. Popular fiction actually has a name for this. They're referred to as the living dead or the undead. Similarly, autonomous robots are non-human things that are somehow too human. So if zombies are undead, then autonomous robots are unhuman. Now, it's said that we humans are made in the image of God, and the imitation of God is considered a blessing as long as he's recognized as our model, as the source of our own autonomy and our freedom and creativity. But as soon as we try to usurp that autonomy and turn God into a rival, as soon as we try to be God, then blessing turns into blasphemy. Autonomous robots are made in the image of humans, and we sense that there's something blasphemous about robots trying to be human. This trying to be human, like our trying to be God, is driven by an obsession with autonomy. But in both cases, we're talking about our autonomy. The obsession we're talking about here is our obsession to keep up the romantic lie of our own autonomy. Whether we're dealing with the true autonomy of God or the perceived autonomy of humans or the pseudo-autonomy of unhumans, mimetic desire, which always wants to point an accusing finger, ends up accusing us. So our feelings of discomfort and suspicion are really unavoidable. This is not immediately obvious to an engineer who wants to characterize the problem in terms of capabilities and controllability, but it falls directly out of the logic of mimetic desire. Let me see if I can explain this in more strictly Girardian terms. In our relationships with our human models, we try to exert our autonomy against someone that is, in a sense, higher than we are. in a position of higher autonomy, in other words, in a godlike position over us. The sense of rivalry and resentment that this inspires is particularly acute when our gods ignore us. That is, when our models don't show the same interest in us that we have in them. In the words of Paul de Michel, whom I'll quote because he might actually be listening here, at the heart of mimesis lies the interest that we have in each other's interest, the flip side of which is the desire of each of us for others to take an interest in what interests us. Humans care not only about the damage they have suffered, but also about the affront. So think, for example, of the narrator in Dostoevsky's Notes from Underground. He's absolutely obsessed with a man that one night in a bar just nonchalantly picks him up by the shoulders and moves him aside and keeps on walking. You know? It's not the the physical violence of the thing that bothers the narrator. It's the fact that this guy doesn't even bother to acknowledge the offense. You know, that he just keeps on walking and doesn't even look back. That really drives him crazy. The suggestion that his own feelings and desires, his own autonomy, are nothing compared to this this self-important officer. As if his life revolves around this guy, which of course it does. His desires are completely defined by his resentment toward this officer, who obviously couldn't care less about him. So similarly, in our own rivalrous relationships, driven by a resentment of our own making, we strive to be more human than we are, as human as our rivals, by trying to exert an autonomy that we don't really possess. In our relationship with autonomous robots, we perceive a model that is in a sense below us, exerting its autonomy against us. But despite the fact that we are the model for their design, we know that they are the model for our desire, because they, like Dostoevsky's officer, don't care at all about us or our desires. Robots are perfectly indifferent to our resentment and our insecurities. We humans are the ones who care and who struggle and can't let things go. So with our human models, we're struggling with a humanness that has a lack of autonomy. With robots, we're struggling with a kind of autonomy that has a lack of humanness. But in both relationships, they're characterized by a competition of autonomy, and both are rivalistic. The latest trends in robotics are showing us now that our mimetic rivalries can extend beyond our human relationships. And apparently when this happens, a kind of transformation occurs. Our human relationships become humanoid relationships. And yet the tendency towards rivalry remains. This rivalry is really a rebellion against our own lack of autonomy, a reaction to anything that threatens to expose this ontological lack. So what we are seeing now is that this threat can come from anywhere, from above or below, from the human or the mechanical, from the real or the artificial. As in any good sci-fi horror movie, you can run, but you can't hide. And this is basically because in the end, what you're running from is yourself. So the upshot of all this is that the relationship between people and robots is really more complex in the sense of being more profound and more existential than the engineering community realizes. It's not necessarily more complex in the sense of being more complicated. Discussions on robotics and AI tend to revolve around increasing complexity of algorithms and technologies and applications, et cetera. But the fact is that most of the truly revolutionary ideas in modern science have been distinguished by a certain simplicity, what we call elegance. For example, the defining equation of Einstein's relativity theory, and the most famous equation in science, is E equals mc squared. Energy is equivalent to mass. It's revolutionary, but simple. At the heart of all the strange complexity of quantum mechanics is Heisenberg's uncertainty principle, which basically says the more you know about one thing, the less you know about another thing. It's powerful, but simple. The huge variety and complexity of biological life stems from the surprisingly simple double helix structure of DNA. So my suspicion is that the complexity of AI will ultimately lead to a key underlying rule or mechanism that is fundamentally simple. And this, I think, will highlight the irrelevance of all this talk of capabilities and controllability. And the conversations will probably converge on a single driving idea that ties everything together. I wouldn't be at all surprised if it turned out to be something like the simple triangular structure of mimetic design. Thank you.
Thank you, Pablo. That was excellent. And I was thinking about my dog who wants to be autonomous, but I don't have to worry because he always demonstrates guilt whenever he does something wrong, like right now. So anyway, I'd like to turn it over to Jeremiah, our respondent. Thank you.
Thank you very much. And thank you, Pablo, for a really outstanding paper. Pablo has this gift of making me feel smart. You know, so when I hear him talk or read what he's written, I'm like, oh yeah, no, I get it. Which it's always way beyond me. So I have to remind myself that I really don't quite get it. But I thought I would sort of try to stay on the conversational level and also somewhat on the level of the attitudinal level. In some ways, maybe I'm a bit of an outlier in that the idea of being able to log in on a computer to some company and order a self-driving car that would come up to my house and I could get in and just say, take me to the station, sounds like a dream come true. So maybe I'm a little bit different. But as you drill down into the problem, the place where I found myself wondering if I am getting it or maybe some disagreement, I'm not sure, is on my copy, it's around page 7. It's around the story with your son. You say the answer, I believe, is that there is indeed a moral factor involved, but it comes after all the decisions are made, not during. And so you're applying the word decision to something that a computer or robot does. And I have a bit of a problem with that, that it's not a decision. And then the use of the language, when your son says a car doesn't know when it's done something wrong, I think that's completely correct. But when you write, the problem is that if a car ever does make a mistake, it won't know that it was a mistake. And I want to say it never makes mistakes. That making a mistake means you know that you've made a mistake. And so that's right, it doesn't, but no. So if it doesn't know it made a mistake, it hasn't made a mistake.
Yes.
And then in connection with that, and by the way, in the back of my mind of listening to your paper a lot was the first episode of Kieślowski's Decalogue, which all revolves around an accident where there's no one to blame. And he's setting up the whole of the 10 films with, and we know that his co-writer was Girardian, with this idea that we really do need to blame someone and what happens when we just have an accident. But you asked this question in the next paragraph. So who is there to blame? Is there anything more tragic than someone dying for no reason, just bad luck, or worse, bad math? I'd say, yeah, being tortured to death is a lot more tragic. You know, that there is something senseless about it. But when you add human evil that is intentional, I think that's even more tragic. But so those are my thoughts that I want to turn over to, and we've got a lot of questions afterwards as well.
Okay. Do I respond now or?
Yeah, please.
No, actually, yes. I'm completely on board. I think you're, well, with one exception. Yes, I think you're right. As far as making decisions, I absolutely agree. I use the word decision rather loosely there, because I'm trying to kind of keep in line with what Elon Musk and Hawkins were saying. You know, I think you're absolutely right. I mean, precisely because a machine is not a human being, is not self-aware, to call it a decision is a bit of a misnomer. I think that's true. But that is kind of the problem. That's why it's not aware that it makes a mistake. It simply does what it's supposed to do. It never makes a mistake. You know, it does what it follows its programming. It can do nothing else. and because of that, it's not aware of what it's doing. This is really what my son was saying. You know, he intuitively understands that, you know, cars never make mistakes. Therefore, when something bad happens, you know, is it a mistake? It certainly feels like a mistake. You know, certainly something bad. You know, so maybe calling it a mistake is not the right thing. But yeah, absolutely. That disconnect is precisely where the problem is. As far as what's more being more tragic, you know, I was being a little bit loose there as well. But I think the question is not what's more, you know, what's more painful or more violent or more evil necessarily, but more tragic. You know, I would suggest that you know, someone being tortured, if they're being tortured for a reason, you know, like a martyr, that's certainly very sad and very hard. But tragic, you know, in the poetic sense, I would say dying for no reason it seems to me more tragic. I mean, it doesn't really matter. It is tragic. You know, which one is more tragic is kind of beside the point. But you know, my point is that it is a horrible thing. It turns our stomachs to think that someone died for no reason. You know, something so terrible can happen for nothing, just because there was a math mistake somewhere. You know, that is just inherently off-putting. Yeah.
In keeping with that, Pablo, Marina comments that she'd rather die from COVID than from the side effects of a COVID vaccine. Same thing, I think, she says, as your examples. Would you agree?
She'd rather die from COVID than a COVID vaccine. Well, I'm certainly not going to delve into a political discussion here. I'm not sure I agree with that. In fact, I guess I just don't. I don't agree with that. I don't see the connection immediately. Maybe I'm just not thinking along the right lines. Maybe it wasn't intended to be a political statement, but it seems to me if you've got a vaccine is intended to cure the problem, if in fact it doesn't, that would certainly be ironic. It would certainly be a bummer, but tragic in the same sense. I'm not sure. You'd still be trying to solve a problem, and if in fact you don't, or you make the problem worse, you know, that's a bad thing. But I don't think it's tragic quite in the same sense as you know, dying for the sake of mathematics. You know.
Marina, and please explain more in the comments if you would like, and we can return to that question.
Yeah, if I'm misinterpreting or putting a different slant on it, that's my fault.
Nikolai says, we're afraid of robots and autonomous systems because they are never autonomous. It's what can happen when those who cannot be trusted take control of robotics. How will we ever have control of that?
Oh, so that suggests that that we're not afraid of robots at all. We're just afraid of each other. We're just afraid of other people that have very sophisticated tools in their hands. We're just afraid of people with stronger weapons. I'm sure there's some truth to that as well. I mean, but it doesn't really address the kind of shift in attitude that we have towards specifically autonomous robotics. I mean, I think that applies to any kind of technology, including robotics. But it doesn't answer the question, why do we feel so differently about autonomous robotics? You know, why that change in attitude after 2012? And why do we feel so squeamish about getting into a self-driving car? You know, who's controlling the car? Are we afraid of, you know, what are we afraid of there? Are we afraid of another person when we step into a self-driving car? Or are we afraid of the car itself?
Thanks. We have a question from a comment from Woody. A typical AI worry is that humans and AI will have divergent purposes, e.g. Bostrom's paperclip maximizer. But Girard makes clear the problems inherent in convergent interests. Which do you think is the greater danger?
So the danger of convergent interests, but let's see if I understand the question. The greater danger, the two dangers being our interests converging with that of robots, and what's the other one?
I'll read it. I'll read the beginning again. He says a typical AI worry is that humans and AI will have divergent purposes, e.g. Bostrom's paper maximizer, which I'm not familiar with, but I suppose others are.
I see. So yeah, so which one's the greater problem, diverging interests or converging interests, which would put us in competition with each other? I see. I wasn't thinking about it along those lines. I think it's a valid question. I suppose in the context of my analysis, I think the greater problem would be the converging interests, because the way I understand the problem, the way I just explained it, it's really the fundamental problem, or the thing that makes us nervous. I mean, what is logistically or technically the problem, maybe another question, but what bothers us so much, what we perceive as the problem, is that robots, their interests are starting to converge with ours. I think that's the suggestion that they are becoming too human, means that their desires are becoming too aligned with our desires. And so we're starting to become models for each other and therefore rivals for each other. So if I had to choose, I would say that would be the greater existential problem. The other one of diverging interest seems to be more of a practical, a logistical or technical problem of making sure robots do what you want them to do. Yeah. I can't hear you.
Sorry, this is from Father Brian Carpenter. He says, this is interesting in light of Dietmar's question as to whether a machine, AI, could in the future be held accountable legally.
Yeah, I saw that question in the first plenary session, actually, and my ears perked up as well. The response to that question was a very quick yes by the speaker, that absolutely robots, autonomous or AI entities, he called them, I think, must be held responsible and morally accountable. And if you think of an AI entity as something that has effectively crossed that threshold into humanity, then I suppose that would be true. But we certainly haven't crossed that threshold yet. Certainly doesn't apply to things like self-driving cars or any of the autonomous robots that we have nowadays. And yet this fear persists. In order to decide whether to hold robots morally accountable for something, you go back to what Jeremiah was saying. If you hold you can program a robot to say, I'm sorry, but is that very satisfying? Is that a sincere apology? Does the robot know it's saying it's sorry? Does it know it's sorry? Does it care? It seems to me the answer is no, by definition of a machine. But I guess that's what we're all talking about here in this conference. At what point do you say, do you start thinking of a robot as being self-aware or as being morally aware? When do you start applying those kinds of rules to a machine? In the context of my paper, I'm assuming that machines are not morally responsible. Sometime in the future, maybe, might have to rewrite this whole paper and reanalyze things once robots become self-aware and cross that threshold. But for now, we have this fear. We have this sort of existential crisis with robots that we're starting to deal with. And I think it's because of this problem of autonomy. If you start, this is a much bigger conversation, but for me, the biggest issue, the bridge you have to cross, if you're going to claim that robots can become human, that robots are going to become self-aware, it implies that simply by increasing a degree of complexity, of algorithmic complexity and mathematical programming, by increasing the degree of that complexity, you can cross a certain threshold into humanity, which I think then implies that we humans are really nothing more than very complex machines. And I think that's a tough argument to make. It seems to me the easier argument that humans are categorically different from machines. And so the question of when do you start treating machines as human beings is not obvious to me anyway.
Yeah, I was actually thinking about whether or not you could program a robot to say, I'm sorry, in a really satisfying way. So.
Yeah, with little puppy dog eyes or, but.
Yeah, and even power. But whatever. This is from Steve McKenna. Another difference between a car and a plane is also that most people know how to drive the former and think of it as easy, but have no experience with operating the later. Also, the pilots running autopilot are still there at the helm, able to switch it off and take over at any moment, or at least that is the passenger's perception. Thus, oddly, we might think of the self-driving car as somehow mindless, zombie-like, while the plane still has the pilot's minds. They're minding things, or at least there is the comforting illusion of that. Could it be that we resent the autonomous robot's complete unsusceptibility to mimetic desire?
Yes, I think we do resent the robot's unsusceptibility to mimetic desire. I think that is the point I was trying to make, that we resent the notion that of something that is trying to be human without being culpable. It's immune to mimetic desire. It's immune to sacrifice. It's immune to any sacrificial mechanisms. And yet it appears to be human. It's acting like a human. So I think, yes, I think that is precisely what we resent. It's interesting, the comparison, it's also true that that occurred to me also. I was kind of right. I didn't want to make the paper too long, but it is worth talking about that. We do tend to think of autopilots differently, and there is usually a pilot, and that is a kind of sense of comfort. Which is why in most self-driving cars, initially they always had a driver there, even if he had his hands off the wheel, but he was there, and that made people feel more comfortable. The fact is that a number of plane crashes have occurred because the pilot didn't do what the autopilot told him to do. There have been a few plane crashes where if the pilot just kept his hands off the stick, everything would have been fine. And it was the reaction of the pilot that caused the crash. So, which gets to the comment I made in my paper that machines can make bad decisions, but people can make bad decisions too. There's no guarantees either way. So from a purely logical standpoint, there's no good reason to trust a person any more than trusting a machine. In fact, a machine will statistically do better than the person. So really, you should put your trust in the machine. That's the logical thing to do. But we're not talking about logic here. My real quick anecdote. Just this morning, I was talking to my father-in-law about this paper. I was explaining to him briefly what I was going to be talking about today. And he was complaining about, about technology nowadays and how, you can't go to the bank anymore and talk to a teller. Now he's got to do everything online himself and with these apps and all this. And he's going, but technology, it's so unreliable. My internet goes out all the time and there's all these glitches on my phone. And I said, yeah, no, that's true. I mean, technology is certainly not super reliable, but people aren't very reliable either, right? People make mistakes all the time too, right? And his answer was, yeah, sure. But, at least if a guy makes a mistake, I can hang him for it. And I said, exactly. I didn't even lead him up to it. I didn't even point him in that direction. It came out of him completely naturally, which gave me confidence to give my paper here today. I said, yes, you just stated the thesis of my paper. Perfect. So, and we were talking about that, about pilots and autopilots and all that. So yeah, it's Sorry, I'm rambling a bit, but it's very good points. Absolutely.
No, it's all important. Here's John Ray. He says marine insurance, regarding marine insurance, AI, autonomous crewless ships, has the issue of who is ultimately responsible in a liability situation. Is it the designer, programmer of the self-learning algorithms, et cetera, who in the development chain has legal liability? Right now, it is the captain of the vessel who is responsible until the insurance issues are settled. Marine AI has implementation, not necessarily technical issues.
Yeah, I think that's right. That goes to that question of, who's responsible, or can you hold a machine responsible? What that example shows is that, at least for now, no, you can't hold a machine responsible. You have to hold a person responsible. And so the question is, which person do you hold responsible? If it's the captain, in that case, then that's really simply because the captain has official authority. It's not because it's the captain's fault. It's not because he did anything wrong. It's just because he is officially the guy in charge. So that's really, it's a purely logistical way to address the situation. But anyone who, whose family member dies or loved one dies in that situation, they're not going to want to blame the captain. They're not going to want to sacrifice the captain. They're going to want to sacrifice whoever's truly responsible. And who's that? Similarly, it can't be the programmer, it can't be the engineer, or any one of the programmers. They're just doing their jobs. They're programming what, they're following all the rules. Nobody is doing anything morally wrong. But like I said in the beginning, you can't simply blame the machine. So you have to pick which person is going to accept responsibility. But it becomes something closer to a ritual, where blame is being transferred onto the responsible party, and this person sort of accepts the sins and takes the sins onto himself. Right? It's got to be something like that, because the machine itself cannot be a scapegoat, cannot be a victim.
The machine's not going to go down with the ship, huh?
No, or it won't care if it does.
Well, but it won't care. Right. So let's see. I've got a question from Eric. Any thoughts on the uncanny valley of roboticist Masahiro Mori?
I'm not familiar with it. Sorry. No. Is that a story, a novel, or what is it?
I'm not sure. If Eric wants to post something down in the chat, we may be able to pick it up later.
Yeah, sorry, not familiar with it.
Now you're getting lots of compliments, Pablo, I just want to say.
Oh, good.
Many.
Those aren't interesting, though. We're the hard hitters.
Well, let's see if we can find one. Here's Ryan. I'm wondering if there is a more basic explanation, one which Singer would call speciesism. There is an idea, at least in fiction, of recognizing technology as being itself a kind of species. It grows and changes over time, much like us biologics. And in response to the idea of robots not knowing when they have done wrong, there are many people who also do not differentiate between moral right and wrong. And yet we would let them drive us somewhere or prepare our food. We might also trust a dog to fetch our mail on its own, yet remain skeptical of an autonomous robot which does chores around the house. See Love, Death, and Robots. Isn't there then a distrust of autonomous robots simply because they aren't biological? That is, because they are simply other and alien to what we normally expect to encounter. Assuming so, how do we collectively begin to bridge the gap and overcome speciesism? There you go, Pablo.
All right. Let's see. So if the problem were certainly being skeptical of the other, of anything that's different, I mean, that certainly makes sense. That's got to be part of the equation. But by itself, if that were the whole story, it doesn't explain why we have a positive attitude towards robotic technology overall. Like I was saying in the beginning of my paper, the attitude towards robotics and towards artificial intelligence from the beginning up to the present day is mostly positive. It's really in relation to autonomous robots that there's a distinctively negative attitude. And, it's not quite that clear a distinction. It's not like, this is data taken from various sources, from the media and journals and stuff. And you kind of have to interpret the data a bit. So, it's not like everything but autonomous robots is good and autonomous robots are bad. But there is that definite sort of trend. So if you're going to just simply, if the root of the problem were simply we don't trust anything that's different from us, then I would think there would be a bigger issue with robotic technology overall, with all types of robots, with all types of technology. And thinking of technology as a kind of species, I think that makes sense to think about it as on a kind of logical level. Technology acts as a kind of species. In certain ways, you can think of it as a kind of different species because it reacts to us and we react to it, and it reacts within its environment and things like that. But is that an analogy, or is it really? Are we saying that technology is like a species, is analogous to a species like us, or are we saying that it actually is a different type of species, a different type of living thing like us? In which case we can hold it morally responsible and accountable for its actions. That latter attitude seems to me very difficult to defend. If you're going, I'm familiar with this, thinking of, describing technology as a kind of species, but I always took that as a kind of analogy. Ultimately, I know not everyone takes that as a kind of analogy, but to me, that seems like an analogy. Otherwise, you're saying technology is a kind of entity, a kind of, maybe not self-aware, but, a kind of living entity in itself. I don't know. That's an interesting discussion. That's a tougher problem. I personally would not simply make that assumption. I would consider that an analogy.
We have a question from Andrew. He says, auto accidents. U.S. insurance companies mostly don't believe in them. There are car crashes mostly owing to unheedful, unthinking drivers in their actuarial view. The auto is the idol of our autonomy, of our autonomy fantasies and pathologies, our romantic lie. Comment?
Well, yeah, I think there's probably some truth to that as well. Of course, insurance companies are trying to make money, right? The last thing they want to do is admit that there's such a thing as an accident, right? They need to blame somebody more than anyone. That's their job. That's how they make money, is by blaming people. So, yeah, I'm sure that's true. Autos being the kind of idol of our society, yeah. I think we're going off on a different tangent there, but I'm sure there's some truth there too. Yeah, I'm not sure I can make intelligent comments on that right now. That's an interesting discussion over beers, I think.
For the chat room later.
Yeah. Do they have beer in the chat room or no?
There are chat rooms, and you can go to those, and I encourage everyone to do so later or in between sessions to continue our conversation on all of these issues, because we won't be able to get to all of the questions, but I hope that we can have really fruitful discussions throughout the conference. But we still have some time here, plenty of time, I think. So here is a question from Eric. What is the precise logical and semantic difference between making a mistake and bringing about an outcome that is not supposed to occur?
Yeah, that's kind of what Jeremiah and I were talking about earlier. Yeah, I'm starting to regret phrasing things that way, calling it a mistake. Yeah, having an outcome that is not, that is not what you wanted, that is an unintended outcome, is certainly not necessarily a mistake. Right? There's a distinction to be made there. But I'm not sure how to answer the question in a way that other than just to kind of agree. I get we probably should not be talking about robots making mistakes. We should be talking about robots doing things that we don't want them to do, having outcomes, unintended outcomes, unintended by the people, by the programmer. Of course, from the robot's perspective, everything is perfectly intentional. But again, intentional implies a sort of self-consciousness. We trip over ourselves on these words all the time. This is what makes the thing so difficult. This is why it's so easy to talk about technology as a species or robots as humans. Because there's this tendency towards anthropomorphism and seeing an unintended outcome and thinking of it as a mistake, which implies a certain responsibility. So yeah, I guess I'll take that as a warning. And I guess we should all take it as a warning to in all these conversations that are over the next few days. I think there's going to be a lot of that. There's going to be a lot of tripping over our own language and our own analogies and our own metaphors. It's going to be very difficult to keep those things straight. Otherwise, it's very easy to just slip into a science fiction story, and this isn't supposed to be science fiction. It's supposed to be the relationship of humans to robots, which is very real. Yeah, so point taken. You're on mute, I think.
This is from David for Jeremiah. He says, Kieslowski was the movie I was thinking on all this time. Who to blame when your child is deaf? And the AI reflection, which is epistemological question, present in the movie with the father's lessons, faith and knowledge are at stake as two different ways to approach the same facts. Do you want to respond, Jeremiah?
No, I appreciate David's comment. I just think if there are those who might not have seen the Decalogue or seen it, but it's been a while, to go back and see that first episode again. It seems to me that part of what he's trying to do is really, and if you compare it with the screenplay, even in the screenplay, they kind of blame someone let out some warm water. And it's not in the movie. That there really is an attempt to make it an accident. The father goes through his mathematical calculations very carefully, but then he goes out and tests it. He doesn't just rely on his math. He goes out and jumps up and down on the ice, and yet still this accident happens. And so I felt very much what Pablo was saying, that we need someone to blame. And I actually, even as he was speaking, I think maybe Pablo's right that the accidental death like that is the most tragic in the kind of almost technical sense of the word tragic. And so I take back a little bit of what I said. Thank you.
This is from Dominic. Do you believe strong AI possible? Could computer autonomy ever equal human autonomy?
I personally don't think so, for the reasons I was saying before, that I think there's a categorical difference between humans and machines that cannot be bridged simply by increasing complexity of the algorithms or the mathematics. Clearly, that's debatable. I think that's going to be debated over the next few days. But for me, the more interesting question is the relationship between human beings and machines and robots, and how robots affect our relationships with each other and with the world around us. And I do think that our relationships with the physical world around us is connected to our relationships with each other as human beings. So robots play a kind of special role, and especially autonomous and artificial intelligence. They play a special role within that, you know. I think that even interacting with objects, with rocks, with cars, with trees, or with anything, is tied up with how we are related to each other. I mean, that's a big part of my book, and the whole quantum mechanical entanglement and all that stuff. I try to explain it in those terms, but ultimately there's a relationship there. And so robots and artificial intelligence are kind of this, they almost lie in this gap between the inanimate world and the world of human beings. So I think it is very important. A conference like this is very important to explore those kinds of questions. How close are robots to humans? Even if they never cross the threshold and become humans, the fact that they appear to be doing so, or the fact that they are kind of encroaching on our territory in ways that are, that reach the core of our humanity, that matters. I think it matters not so much because robots are going to become self-aware and take over the world. It matters because it affects how we relate to each other and to the world around us.
I suppose robots could become our common enemy, huh?
Yeah, well, they could. That may be a role that they could fill. Exactly, even if they don't, even if they are kind of immune to sacrifice themselves, can we sacrifice each other through robots, through a kind of surrogate sacrifice? I mean, that could be an interesting outcome of development of AI. I don't know.
So we have Barry says, I am thinking of the Tower of Siloam in Luke 13. It's been a while since I read that story. But Jeremiah or Pablo, are you familiar with it?
No, I'm not.
But yeah, it's the story where the Galileans come to Jesus and talk about their countrymen whose blood had been mixed in sacrifice by Pilate. And Jesus says, or do you think they were any more guilty than others because they suffered this way? Absolutely not. He completely denies it. And then he brings up the thing about the people who got killed with falling of a tower, so just an accident. Do you think they were guilty of sin more than others? Absolutely not. Then he goes on, and both times he says, but you are going to suffer a worse fate if you don't repent. And I take that to mean that if you're trapped in this world where you think people are suffering because they are being punished by God or because of their inherent evil, then eventually that tower is going to fall on you. And so I think that what the Gospels actually enable, and I don't know quite how to tie this into robotics, but it is this idea that we don't need to have someone to blame, that somehow the tragic death that seems like it's without meaning on a human level is somehow part of God's plan. And so that should relieve us of a need to have someone to hang for it. Those are my thoughts.
Thanks, Jeremiah. Pablo, do you want to tie that into robotics?
No. I I think that was a good last word. I'll let Jeremiah have the last word on that one. Nothing to improve on there.
Okay, let's look. Teresa says, wouldn't we always blame the engineers per manufacturers and hold them legally and maybe morally culpable, no matter how advanced such cars or systems would become? So I guess saying, isn't there always someone to blame?
Yeah, yeah. Well, speaking as an engineer, I think that idea sucks personally, but it goes back to the to what we were saying before, that what you're doing is you're looking for someone to blame because you can't blame the machine itself. So holding the engineers accountable, seems like a logical thing to do since the engineers built the machine. But I think it's the same as the captain. You're simply assigning a kind of surrogate victim, basically, someone to take the place of the machine since there's no one else around. I mean, would anyone here, I forgot who asked the question, but would that person or anyone feel satisfied if we held, the engineer that wrote the code for some self-driving cars or whatever, any autonomous robot? If we track that person down, engineer, Tony the engineer, and say, hey, we've decided to make you responsible. Say you're sorry. Would you be satisfied by that? Would that be, I don't think so. Which implies that, you're really just trying to find a victim somewhere. You're looking for someone to blame.
Richard says, is the driverless math mistake somewhere that kills me in an accident comparable to the driver who kills me? Tragedy doesn't matter to my dead self.
Well, you mean it doesn't matter to you? Well, no, after the fact, if you're dead, of course, with all debates disappear. But the question is, why don't you want to get it into that car in the first place? Before you're dead. What makes you so afraid of dying in the first place? Why aren't you afraid of dying when you get into a taxi or an Uber? Why are you afraid of dying only when you get into a self-driving car? And that's the question. That's when it matters to you. And I think there is a difference, intuitively, the point of my paper, between a math mistake and which, as we were just saying, is not really a mistake, strictly speaking, and an actual mistake made by a person, which really is a mistake. It's okay to be the victim of a mistake. It's not okay to be the victim of bad math. So I think that's the distinction.
And bad math won't sell autonomous vehicles.
No.
So here is Martha. You stated that the human-like aspects of autonomous vehicles, which bother us, is that they are model rival. We resent because they are more human than us. But isn't it the case that the most human aspect of us is our lack of being? In the absence of the fullness, sorry about my dog, in the absence of the fullness of being, we are mortal and die. We are resentful because the autonomous robot appears to us as a human who will never die. Of course, robots get thrown into the dumpster, but they do not die. Only humans die. That is self-awareness. That is why zombies bother us. They too are humans who never die. They are the undead. And this element of the uncanny is also what drives the uncanny valley phenomenon.
I don't think I would disagree with that. I think that speaks to the same issue. I would make one slight change. It's not that. Let me see that. I'm trying to capture the phrase. She quoted me, and I'm trying to remember exactly what the quote was. Can you read that? What her quote of me? What did she say I said?
Okay, I'm looking at it. You stated that the human-like aspects of autonomous vehicles which bother us is that they are a model rival we resent because they are more human than us.
Okay, that was it. It's not that they are more human than us. Of course, they aren't, right? But that they have this quality of autonomy, which they only have in a kind of mathematical sense, but which is starting to look like human autonomy. That gives the impression that they are becoming human, but human in a way, not just human, but human as a model rival. They are becoming our rivals in the worst possible way. They're becoming the kind of rivals that we envy because they have autonomy. It's this perceived autonomy, the same way we perceive autonomy in a model which may not have it, a model which may not even care or know anything about you, but we perceive that the model has this autonomy and this power that we don't have. And that's what makes that model our rival, because we envy that autonomy. That's the thing that we see in robots, but it's coming from us. It's not an inherent quality of the robot. The robot doesn't actually have human autonomy. The robot is not actually being more human than we are. That's just how we are starting to see it. It's starting to look like that kind of humanness that is the kind of humanness that is more human than us, and that's what it's instinctively scandalous to us. But the robot itself is an object, is not a human, does not have this autonomy that you are starting to see in it. It's really coming from you.
That's really interesting. We may experience it as a model obstacle relationship, but it's one-sided. They cannot participate in that, really.
Yeah.
Or at least in the terms of
and with human models, of course, it can go both ways, and you can have the double binds and this sort of reinforcing relationship, and you can end up attacking and killing each other. But in the case of robots, you're not going to work the robot up into a frenzy. The robot doesn't care about you, but you're going to work yourself up into a frenzy to the point where you will attack the robot or kill yourself trying. But it's all coming from you.
Interesting. This is from George. I agree with Pablo that death by an immoral agent is less disturbing because it's at least understandable and human than death by an amoral agent, implying a universe without meaning.
Yeah, I would agree, yes.
This is from Lindsay. I think the problem of intentional human evil versus dying for no reason are both terrible tragedies in different ways. From a Girardian perspective, having no one to blame just leaves a terrible pent-up frustration with nowhere to go. There is all this anger and sorrow, but we can't get mad at machines themselves. But we can have anger at the concept of a machine having the power that can make tragedies happen, even if they prevent more tragedies than they cause. It may be misdirected, but we still have the desire to blame something. I hadn't really connected AI and the scapegoat mechanism before this talk, but this makes sense to me.
Good. Yeah, well, I'm glad. Yes, I think that's absolutely right. Yeah, and the nature of a tragedy is we're all these comparisons that we're making between human and non-human, between mistakes or not mistakes, or responsible or not responsible, or in this case between something that is tragic because it's senseless or tragic because it's intentionally evil. The fundamental gap between all of these is, are you talking about a self-aware thing or a machine, you know? Are you talking about a human or something that is just pretending to be human or like a human, or, you know, but not really human? That's why I think these discussions of, you know, is it possible for a machine to become self-aware, or can you hold a machine morally accountable? I think all these distinctions we're making, to me, implies that we all intuitively would answer that question: no, a machine is not morally accountable. You can't hold a machine morally accountable. All the questions and the comments that I've seen so far, that I've heard so far, would seem to suggest that everyone intuitively knows you can't hold a machine morally accountable. You need a person, you know, but you need that person. You can't just have nothing. You need a person.
So we have reached 8 o'clock. I just realized it's a few minutes past, and I really encourage everyone to scan through the comments, because Eric has, for instance, posted a link to his essay. I believe it's his essay, The Uncanny Valley. And there are other links that people have posted related to our topic. And I hope that this is all available for a while. Will the chat be available for people to go back and look at? But I'm sorry that we couldn't get to all of the questions and comments. There were a total of 61, Pablo. So I think you have really stimulated discussion today. And I want to thank both you, Pablo and Jeremiah, for a really great talk. And Pablo, it was really wonderful to have you share all of your expertise with us. Oh boy, I mean, I think this conference was just made for you in a sense.
I've been looking forward to it for 2 years now.
Yeah, it's really great. So please, everyone, I think we have another session tonight, another concurrent session, or is that true? Or we have at 8:30, we have plenary session number 3. It's the Gerard 101 lecture. But I also really encourage people to go to the chat rooms and hang out and continue the discussion. That's something we love about the Cover Conference, is that we get to share all these great ideas through the late hours of the evening. So please do that. Thank you.
Thank you, Susan. Thank you for your moderating. Appreciate it.
Thank you. Thank you, everyone. I appreciate it.